Hey everybody, we are back. Our next talk is going to be by Noel Rappin, but before I introduce him in the talk, I just want to give another shout out to our sponsor, Hired.com. If you're looking for a job or thinking about looking for a job, go to Hired.com/RubyRemoteConf. They have auctions from a lot of companies in a lot of the major metropolitan areas in the United States. Where they're bidding on developers just like you. So if you are looking for a job, they do give out a $2,000 signing bonus if you sign up with any of the companies that they bring to you. But if you use our link, you get a $4,000 bonus instead. So go check them out. That's hire.com/RubyRemoteConf. And I'll go ahead and introduce our talk here. We'll be talking about what we talk about when we talk about testing. And just a sec, the intro notes closed on me.
I just got kicked out. And I'm back.
So Noel is the Director of Talent at TableXI. He's authored multiple technical books, including Rails 4 Test Prescriptions, Master Time and Space with JavaScript, and Trust-Driven Development. And you can follow him on Twitter at Noel Rapp and online at noelrappin.com. So take it away, Noel.
Hey, that's me. Hi. I had a feeling this was going to feel tremendously strange to be sort of in giving talk mode to my laptop, and I seriously considered setting up a soundboard so that I could have applause and laugh effects, but I decided that would it would be ridiculous. But if I chuckle for a soundtrack, you should just go with it. So I'm Noel Rappin. I work for TableXI, a consulting shop in Chicago, and I want to talk about what we talk about when we talk about testing, or thanks, Chuck, or beyond Red Green Refactor. So I can't obviously ask for a show of hands, but one thing I want you to think about right now is, do you test, all of you out there? Do you feel guilty about not testing more? And if so, like, what is the source of that? What do you feel like you don't test enough? Do you feel like you're not test driven? Do you feel like you let testing slide? Do you feel like your cover doesn't? Do you feel like you don't test enough to feel confident in the code you write? I guess is the thing that we're going. Test plus one, guilt plus one. Do your tests drive your design? And what does that mean when we say tests drive design? I think that those of us who, including myself, who advocate for test-driven development have a tendency to talk about it as though it's really easy. And I think that there's some logical reasons for that. I think that for part of that is because if you've done it for a while, you sometimes you don't see the barriers to entry. And also, if it's something that's been successful for you and you are trying to advocate for testing to people who have never done it before, leading with, hey, this is going to be really complicated, often is not the best way to get people excited about the process that you're trying to teach. But none of that changes the fact that TDD is hard. There are specific skills involved with it, and it often is counterintuitive. There are some things we want it to be as simple as it looks in some of the tutorials, but again, like, it's not always clear to a new person like what those skills are, how to apply TDD to a problem, or really how TDD works, like what makes it effective. When we say that testing drives design, what does it mean to drive design, and how does testing do that? Like, how do all these pieces fit together? The classic definition of how TDD works was Kent Beck. When Kent Beck wrote about this initially in the XP book, he started with write a failing test, do the simplest thing that could possibly work, and then refactor as the 3 steps in test-driven development, what he was then calling test-first development. And this eventually got simplified to Red Green Refactor. Red for the color of the failing test, green for the color of the passing test. Those of you who have been doing TDD long enough to have done it before Ruby and RSpec may remember that in the original S unit and in J unit, that wasn't little dots going across a terminal. It was an actual GUI with an actual progress bar that would turn red once it hit a failing test. So that's sort of the instruction that we give people. Red Green Refactor. But Red Green Refactor is a much better slogan than it is an instruction manual. And the fact is that all of these steps come with questions that are non-trivial. We talk about what test do I write next? Are you still getting my video, or are you getting Aja?
We've got both of you.
Okay.
I will fix that.
Okay. So what test? When I go to write a failing test, like what test do I write next? When do I know that? When do I write integration tests? When do I write unit tests? When do I know that I've tested enough error conditions? How much detail do I need to do the error conditions in? And then we get to what is the simplest thing that could possibly work? What do I mean by simplest? What do I mean by work? And refactor has its own issues, like when is it time to refactor? What am I looking for? And all of this sort of has one common root at the top of it, which is how do I split the problem that I'm trying to solve into small testable components? We talk about unit testing sometimes as though everybody always knows where units are. But in fact, that's a hard problem in and of itself. How do I determine what these units are, and how do I figure out how to test them? And one thing that I see a lot is a lot of problems that are easy to acceptance test but hard to unit test. And one of the places that I see this is that one of the things I've been doing for the last couple of years is evaluating code submissions that come in for people who apply for a job to TableXI. And the problem that we ask them to solve has this characteristic. It's really easy to acceptance test, which is to say that if I give you the problem, then it's very easy for me to validate whether the answer is correct or not. But if I give you, it's very hard for me to see into that problem for the individual pieces of that that I want to go in and test. And in fact, I see a lot of solutions where somebody comes in and gives me some acceptance tests but no unit tests. And in 2 plus years of doing this, I've seen maybe a handful of submissions that actually had they actually had full unit test suites, and a bunch that had acceptance test suites, and actually a bunch more that had no tests at all, which I'm not recommending. I don't want to talk about that problem. I'm not going to talk about the problem that we actually use in our coding environment right now, partially because I don't want to give it away, and partially because it's a little bit too complicated to really get at the ideas that I want to talk about. But I'm going to talk about a problem that has a similar quality, which is to say, again, that it's really easy to acceptance test part of it, but hard to see into the guts of it necessarily to see how to unit test it. This problem is maybe a little bit more explicit or a little bit easier. This originally was presented to me as a 4th grade math problem that I actually found, took and tried to figure out how to code because I thought it was kind of neat in a little kind of a code kind of way. So the problem that I want to talk about testing is finding the unique sequences of digits 1 to 9, for example, 1, 1, 2, 3, 8, that have the following characteristics. The sum of them is 15. They have at least one digit that appears exactly twice, no digit that appears more than twice, and the order is irrelevant, which means that 1, 1, 2, 3, 8 is the same as like 1, 1, 3, 8, 2. And it turns out that the original question was how many of these are there, and it turns out that there's 38 of them. By the way, if you want to follow along, the code for this and the tests is actually GitHub spec Noel Rappin spec_sequence. I'll show the URL again at the end. You're not following along well, so this will be able to give you all the code at the end of this if you want to go back and look at what I did. which is far from the only way to solve this problem. So the question becomes, and what I want to talk about here is how do I test this and specifically how do I use TDD to approach the design of this code? Like not just like how can I validate this, but how can I actually use TDD to drive the code that I write? And we start off with maybe the biggest acceptance test, which is probably a bad idea. This is probably not the right place to start. Here we're starting with, this is our spec, but the specific choice of tool doesn't matter. We're starting with the idea, a test that says, we're solving the whole problem. Expect that the number of solutions is 38. This will validate whether my solution is right or not, assuming that I know the answer before I start, which I might not. But it doesn't really give me any guidance as to what code to write. It's way too abstract and way too far away from individual pieces of the algorithm to understand what to do next. So here's something that's a little bit better and a little bit easier to get my head around to start with, which is to talk about an individual sequence. So here's one individual sequence. I can't even write on this. I've got a sequence class. I'm taking in a list of integers, and I expect this to be valid. And this test I can actually make pass, I think. Well, I mean, wait a second. How would I make that test pass? Well, I can make the test pass, again, for the definition of like do the simplest thing that could possibly work. And the definition that I like to use here is that work means make the test pass, or often work just means clear the current error. So what I wind up with is something like this. All I have is an individual class and a valid method that returns true. If you go back to the test, actually, you can break this into error by error pieces here. The first error that would come up would be, if starting from no code, the first error would be that the class sequence doesn't exist. You create a dummy sequence class, an empty sequence class, and then it will tell you that it needs the initializer to have multiple arguments, and then it will tell you that valid doesn't exist, and then you write valid equals true, and you get to here, and the test passes.
You cut out for about a minute there.
From when to when?
Back up a couple of slides.
Okay. So.
Oh, everyone else heard it solidly. It was just me. Okay, keep going. Sorry.
Technology! Yay! Okay. So we get here. What was I even saying? Oh, yes. So we get here, and the test passes. And one of the things that I think is I often try to get across to people who are new to test-driven development. Well, first of all, I remember what I was going to say. Is that as I describe these things step by step, taking all those steps and saying that I ran this test like 4 times to get to this point makes it sound like a lot of work, but in practice, it actually doesn't take very much more time than it does to type it. And we're talking at about 30 seconds to a minute in of my time to get to this point. And the thing about this point is we're not done, but this is okay. This is a perfectly good intermediate step. It's a perfectly good place to be. I wouldn't check this in. I'm not ready to have it be reviewed, but it's a step in the process. It's a step that's sometimes called sliming the test, by which I mean that Gary Bernhardt called it that once in a Destroy Software episode, and I like the uses so much that I try to pass it along. And this is okay specifically because it's not permanent. But it does kind of beg the question of where we go from here. Like now we have done a red, we have gotten to green, we don't really have anything to refactor. And so now the question becomes, what's the next test? And in general, there are 2 options at any point about where to go next. The first one is to kind of stay at the same abstraction level and write a test case that fails given the current state of the code. That's actually pretty easy for us right now. We're assuming that all sequences are valid. So all we need to do is write a test for a sequence that's not valid. This sequence doesn't add to 15, I think, so it's not valid. But the state of the code will assume that all tests are valid, and this test will fail. This is often a very good option. In this case, it doesn't really help because it leads us to another round of like how do we make this test pass? And it's not immediately clear in like the first 15 or 30 seconds or even a little bit longer how we would write a small amount of code to make this test pass. Which leads me to kind of a rule of thumb. If it's not clear how you can make a test pass from writing the test, there's probably a smaller, more focused test that you can write that would be clear and would clarify part of the implementation. So often you drop to option 2, which is to take a less abstract or a smaller piece of the feature and write a failing test for that. Now, this is part of where the design happens. This is where you start to think about the problem and you start searching for smaller parts of the test. Now, sometimes you'll find a smaller test, and the smaller feature is so small that it's not worth writing a test for. That happens occasionally. The test is it's just a very basic one-liner. But normally, you're looking for something that is part of the feature that you're writing, or a very specific piece of a case. Sometimes an error case would be a more focused test that would drive some kind of development. In this case, we already have a certain amount of structure to the problem, and one of the things about this problem that I meant to say earlier, actually, is that while the pieces of it seem kind of arbitrary, it's actually isomorphic or roughly isomorphic to a lot of kind of business logic-y problems about inventory or scheduling or even some financial things where you actually do have a case where something is very clearly valid or not based on what seem like somewhat arbitrary business logic. So while this is sort of an abstract little math problem, it's structured similar to some things that I've come across in more business logic-y kind of cases. So in this case, though, like we have all of these individual components. The problem, the sequences need to sum to 15. They need to have a pair of digits. They need to not have a trio of digits and something like that. And each of those are smaller pieces of the code that we can test individually. So, for example, we can write a test that says that the sum is 15, which is only one piece. Again, we've dropped a level of abstraction to a more focused unit, a more focused piece of the code that we've said that there's a method here that tells whether the sequence has the correct sum as a component of being valid. And this is a sequence that's not going to be overall valid, but it will have a correct sum. And so we're making a statement here about the structure of this sequence class, namely that it's going to have this correct sum question mark method, and we're writing a test that enables us to get at this one little focused piece of functionality. Okay? Now, I think this is a good step forward, and one of the reasons why I think this is a good step forward is because the code that comes out of this is small enough that I can write it without thinking too hard. Now we're just testing whether a sequence of numbers has an expected sum. That's basically a one-liner. Not only do I know how to do that, but I can also write a negated test pretty easily. So I can say that this sequence does not have the correct sum. And one of the things that this goes to is an idea that that test-driven development should reduce your cognitive load. That if you're doing it well, test-driven development allows you to get past the parts of the problem that are easy relatively quickly and in a relatively focused way, and not have to worry about that when you're starting to worry about the parts of the problem that are genuinely hard. You're not cluttering you're not cluttering more of the problem to deal with at once than you need to. This is not just the goal of test-driven development. It's also a lot of the goal of object-oriented modeling and even certain kinds of function. Like almost all kinds of programming structure have at base this idea that they're going to reduce the programmer's cognitive load by limiting the number of things that you have to care about at once. And test-driven development can definitely do that for you. Now I don't have to worry for a while about whether this code accurately deals with that must sum to 15 part of the predicate. So from there, like the path before me has kind of been set now. I can write a test for whether something has a digit pair. does not have a digit trio, I can write a test for whether a sequence is sort of uniquely expressed in the code, which operationalizes as whether the digits are sorted in some sort of canonical order. So I can write all of these individual pieces, and I hope that it's somewhat clear how that would go. I can write a simple test to see whether a sequence has a digit pair, a simple test to see whether it has a digit trio, and by focusing these tests, by focusing on these very small elements of the problem, breaking the problem down into these small elements, I am making these methods simple, making their interaction relatively simple, and enabling me to focus on them one at a time. And once they're all there, then I come back to that test that says that this one particular sequence is not valid. And now, having done all these individual pieces, I can clearly see how to write the code for this. It's clearly it clearly becomes that a sequence is valid if it has all of those features. If it has the correct sum, if it has the correct distribution of digits, if it has a pair and things like that. Those pieces snap together more simply than they would if I had tried to tackle the whole thing at once. So when we're talking about testing driving design, one of the things that testing does here, test-driven development, in the way that is effective for me, one of the ways that works is that it encourages me to think about the problem in small chunks and then enables me to sort of put those pieces together to build larger functionality in a way that would be more complicated if I was trying to build the larger piece all at once. Okay, so that's kind of a plan that is a tiny little bit more operational than Red Green Refactor. You start with some sort of overarching end-to-end test that takes you through this entire interaction and maybe doesn't depend too much on the internal structure of the code. In this case, we're talking about valid versus invalid, or in other cases, in a Rails application, you might be talking about something that's interacting with the web stack directly rather than the code. You find a piece of it that can be encapsulated. In this case, we were talking about individual pieces of the logic, whether it's a correct sum or those individual validation pieces. In a Rails context, that might be encapsulating out the workflow aspects of the interaction with the database, or some sort of object that has its own that has ownership of a certain specific piece of the logic that you're talking about. Testing a happy path solution, you test the correct, the most expected case, the common case, that it does what you expect. Obviously, it helps to know what you expect to make this work. And then once you have that working, you try to break it. And so this may involve finding a case that you don't think this should involve finding a case that you don't think the code handles. So what happens if we pass in a nil? What happens if we pass in an empty list? What happens if we pass in a negative number? We haven't really, in this particular case, haven't really validated that the digits are all between 1 and 9, which I probably should do. Individual cases will have individual tolerances for different kinds of errors, and how important it is to test all of the error cases before you feel robust. But this is where you do it. You after you get the test clean, then you try and do the error cases. And then when your error cases cease to break the solution, then you're basically done when you can't think of another way to break it. All that said, this is really only validating going back to that problem, going back to this math problem. Validating that an individual sequence matches those criteria is actually only part of the problem. There's one more piece of it, which is that I need to go through the entire universe of possible sequences to get to that 38, the 38 unique sequences. And this is a kind of problem I think that intuitively seems hard to test. Like, it seems like we're kind of testing the edges of the universe somehow. How do I test that? How can I test? What are the pieces of this that I can test other than just saying I find 38 of them? And this is where I think it helps to, we do a little bit of analysis to break down. This is where it helps to get in the habit of trying to break down a problem into testable components. Like, what is a testable component of looping over these possible sequences? And I think about, like, what am I trying to accomplish with this code? And what can I say about this? What are the invariants? What kind of testable assertions can I make? And I want to talk about how I actually did approach this when I went to solve the problem. Like, for example, there are, in theory at least, like 9 to the 15th combinations of this, ranging from like the individual digit 1 to 15 nines, are all kind of theoretically in the solution space for this. That's 205 trillion. And my laptop's fast, but I think we could probably do better than that. And one of the insight that I had as I was trying to solve this problem, and as I was going through this process in my head of trying to think about how I would test this and what sort of individual components that I had, was thinking about a testable unit of this would be in a very sort of enumerable list processing kind of way. When I test one sequence, I then need to make a decision about what sequence to test next. So that's kind of the individual unit of this. Is I have this trend. You think about all of the possible solutions to this problem, from 1 to 99999 whatever. They're all sort of ordered, and I need to go from one to the next. So okay, that framing the problem that way gives me a structure to kind of hang it on. I can make a test that says when I start with one sequence, like, what is the next sequence in that order? And another insight that I had as I was thinking about that solution space and all of these possible mathematical solutions is that the existence of some of the solutions, the existence of some sequences sort of precludes longer sequences. If you think about what the problem is in terms of, like, it has to have 2 digits, it can't have 3 digits, like any sequence that starts with 111 is automatically eliminated. Like, if I have 111, I know that I can eliminate 1112. I don't even need to look at them. So some of the logic that I'm already using for validating can be used to determine this traversal logic. I hope this makes sense. If I'm going a little bit too fast or blowing over the pieces of the problem, let me know in the chat room. I'm used to being able to see people nod or have blank stares at me when I've given this talk in the past. 3 people are typing now. Nodding, hurting solidly, nodding. Okay. Okay. So thinking about this and thinking about this gives me a testable assertion. When I have a sequence, what sequence should come next? And as I kind of structured this piece by piece, and I didn't come up with this all at once, but this was as it sort of played out. As this sort of played out, it occurred to me that there were only about 6 or 7 useful cases, interesting cases. If I started with an empty sequence, I wanted that to go to the sequence 1. And just in my head, I started thinking of this as a breadth first search. So the sequence 1 would then lead to the sequence 11, which would lead to 111. And then I don't need to go to 1111 because I already know that anything after 111 doesn't count anymore. So I can just increment 111 to become 112, and so on. Like doing something similar when the sum of the sequence goes over 15, I can chop off the last digit and increment the next to last digit, which is what happens in that longest sequence there. And I can keep doing that when the sequences get over 10. So if I have the sequence 195, I can then, the next case on that would be the sequence 2 because 196 would be too high, and then I would increment 19, which would 110 isn't possible either, so that takes me to 2. And as it turns out, the last sequence that you get is 96, and then it returns nil. It was not quite this simple in practice. There was a little bit of trial and error. But the key insight though was that I had this structure where I could, in a very sort of Ruby numeral kind of way, think about the sequence as each sequence is having a next component. So this implies kind of a function takes one sequence and returns the next. and enabled me to write a bunch of really simple tests. All of these tests wound up being really straightforward to write. The transitions at the start, I actually, for some reason, did not update the descriptions on this, which would seem to be a thing you would expect me to do. But if you go from a blank sequence, you get 1. If you start from 1, then you go to 1, 1, and so on. And I converted all 7 of those cases into tests one by one, and made them all pass one by one. I'm not going to show the final code you can see in the GitHub repo. It turned out to be about like 10 or 15 lines that I always kind of wish I could go back and factor a little bit more cleanly. But it turns out that having that, thinking about how I wanted to structure this and thinking about it specifically in terms of how I could break this into parts of the code that I could make testable assertions about, led me to think about the code in ways where each of these individual transitions was relatively simple to add to the existing code base. Involved only one clause or one if clause or something like that. And that, if you actually do this, it turns out that you actually only detect 9,825 sequences, and it goes really, really fast, and you find 38 of them that work. At least that's what I hope it does. That's what it did the last time I ran it. So that was how I solved this really simple, well, not really simple, but that was how I solved this somewhat arbitrary problem with test-driven development. I thought about what individual pieces of the program would take me part of the way there and how I could make testable assertions about them. And then I used that knowledge to help me make incremental progress towards solving the problem. So where is that design? Well, the design comes in really in 3 places. The design comes in like at the beginning. As we write the end-to-end test, we talk about what the functionality is overall. And in this case, it's relatively simple. The functionality is we need to calculate how many total sequences there are, and we need to calculate like whether an individual sequence matches that somewhat arbitrary list of demands. But as we encapsulate into code, we talk about there being a sequence class. We talk about it having a valid function. All of these are design issues, and they're all happening as we write that first test. That's the thought process that we're going through. And then when we start writing the internal tests, we're designing the internal API of the code. We're designing that the code is split off into these small little methods, each of which does one little part. And if we were doing this as part of a larger set of objects, if it was a larger problem, we would be also designing how those individual parts of the program would be communicating with each other as we write these individual tests. You really, you write the tests to sort of reflect the way you want the code to behave and the way you want things to look. And then after you passing test, you refactor, and that helps keep the design up to date with the latest functionality. You all think you're having audio problems, but actually I'm just I'm just choppy. I just talk choppy. And when you refactor, and again, this problem is somewhat simplified, but when you refactor, you're starting to look for things that when you refactor, you start to look for things like, do I have duplication here? Is this method getting long? Are these individual lines of code getting long? Do we have a set of functions that all sort of work together on the same data that implies that we have a class or some other kind of abstraction in the code kind of fighting to get out? All of those things are the kinds of things you look for in the refactor step. So that's sort of where, in my head, how you think about design as driving testing, and that's how I think about operationalizing testing. That's how that is what I do. So I hope I'll take questions in a second. If you want to follow along, the problem statement, I think the problem statement is on the README of the GitHub repo. If it's not, I'll put it there in a second. the GitHub the code for this is at Noel Rappin /spec sequence. There's not a lot of code, but it's an interesting problem to try and TDD, in part because of its kind of arbitrariness. I encourage you to try and do this and to go through the same sort of process, and in particular to try and do that same sort of process on the sequencing part, not just on the validity part, because the sequencing part is I think less traditionally amenable to TDD. That's what I have here. I think we will have some time for questions. There's a couple things that I just want to mention before I wrap up. First of all, thanks, Chuck. Thanks all of you for sitting through this. Thanks, Chuck, for putting this together and asking me to present. It's been fun to put together. Just a couple things. Like I said, I work for a consulting shop called TableXI, which is you can find us at tablexi.com. We are looking for people, especially if you are or know a strong HTML, CSS, JavaScript implementer, front-end implementer. They should go to tablexi.com and look around. If you're a junior developer, we are probably looking for that sometime, maybe not immediately, but in the next couple months towards the end of the summer, if you are or know a junior developer. The front-end developers can be remote. Junior developers, a little bit less comfortable with remote, but maybe if you're in Chicago. You can follow me on Twitter at Noel Rapp, where I mostly talk about random stuff. And as I said in the intro, I write some things that you can read in exchange for money. I have a book from Pragmatic called Rails 4 Test Prescriptions, which you can get at that pragprog.com URL. This would be a really bad time for the audio to kick out, at least for me, probably just fine for you. I have a book called Trust Driven Development, which is about surviving software projects and dealing with clients, which you can get at noelrappin.com/TRDD for Trust Driven Development. I like it. It hasn't sold super great yet, but I have a lot of fun writing it. And just today, I launched a Patreon crowdfunding thing for Patreon/Noel Rapp for something that I'm calling Locally Sourced. Which is an attempt for me to try and write chapter length. If you think of tech books as novels, locally sourced will be like chapters or short stories to help me write, sustain being able to write 15 or 20 page examples to solve useful problems that people will be able to get and read. So if you go to patreon.com/Noel Rapp, it's kind of lonely there right now. We're just starting on that. Hopefully that will go through. Again, thank you for your time and attention, and I can take some questions in the chat room if people have questions. And I'm going to stop scratching my nose too, because I bet that's distracting. So the question here in the chat room is, if I'm planning on exposing one method, would I expose private methods to help with tests? That current sum seems like it would be private. I normally, and this is maybe more quirk than anything else, I really dislike having private methods, in part because they're awkward in testing. I can see a design of this where you think that those current things are private. In Ruby, you actually can test that anyway using send, or the variants on send that expose privates. In general, I don't use private methods, and if I have a lot of private methods, that often implies to me that I need a different a new object rather than that my implementation is wrong. But normally, if I do have something that's legitimately private, then I would test it through the public interface. The private method is supposed to be an implementation detail, and I would try not to touch it from a test. Yeah. Right. So Federico is asking something similar. That we're talking about splitting the code into smaller helper methods. Yeah, I mean, as I wrote this, there's a public API, and yeah, so I would move them. I might move them to another class. In this case, it'd be so small that it'd probably not be worth it. And as it turned out, as I wrote this, I wound up using some of those validation tests again in the sequencing part. So it turned out to be useful to have them around.
I see people typing.
Yep.
All right. Well, it doesn't look like we have any other questions. So thanks, Noel.
All right. Wait, whoa.
Oh! I did that to Phil on the last one too.
If you have further questions, you can also hit me up on Twitter too. Have I done mutation testing? I have to find I'm not completely confident in my solution because I can't guarantee it actually covers every possible code path. I have done mutation testing, although not in Ruby. I should say not in production Ruby. I've played with it a little bit. Quite a long time ago, I inherited a code base that was so poorly structured that it was not super amenable to unit testing, and we wrote a bunch of acceptance level tests. Yeah, we wrote a bunch of acceptance level tests. Yeah. Sorry, I locked myself out of my computer. We wrote a bunch of acceptance level tests, and then we used mutation testing on them to guarantee that the acceptance tests covered as much of the code base as we actually possibly could. That kind of thing it's really helpful for. I would potentially do it in Ruby in a very focused way for something that was really algorithmic. I think in a Rails setup, it has the potential to take forever. But I think it's it's an interesting tool, and I haven't done as much with it recently as probably is worth doing.
So
Yeah,
Doug pointed out your algorithmic testing approach seems similar to property-based testing.
Yeah, it is. That I didn't know that term at the time, but yeah, it's pretty similar. It is. There's a lot of similarities. When Jessica and I had a lot to talk about that when I met her in person last year at Windy City Rails, which I recommend if anybody's in the Chicago area. I'll be giving the next generation of this talk there at Windy City Rails. Cool. Well, unless there are any other questions, if there are other questions, you can hit me online on Twitter. Otherwise, I appreciate your time and hope you take a look at some of the other stuff that I had, and hope to see you around in person somewhere sometime. And thanks.
All right. Thanks, Noel. All right. We are going to go into presenter mode so that Aja can get set up. We'll be back in about 15 minutes.